For most of the 20th century, Pluto was treated as exactly the kind of place you'd expect at the far edge of the solar system. Cold, dead, frozen solid, and utterly unchanging. A ball of ice billions of kilometers from the sun, with barely enough energy reaching it to matter, should have no business doing anything interesting at all. Then in the summer of 2015, a spacecraft that had been traveling for 9 years finally arrived close enough to actually look. And what it found broke that assumption completely. Pluto isn't dead. Something down there is still moving, still flowing, still reshaping the surface in ways that shouldn't be possible on a world this small, this cold, and this far from any obvious source of heat. The spacecraft responsible for this discovery was NASA's New Horizons, launched in January 2006, and aimed at a target so distant and so poorly understood that even the best telescopes on Earth could only resolve it as a fuzzy, indistinct blob. For 9.5 years, it crossed the solar system, and on July 14, 2015, it finally swept past Pluto at more than 30,000 miles an hour, capturing more detailed images of the dwarf planet's surface in a few hours than humanity had gathered in the entire 8.5 decades since its discovery. Because Pluto is so far from Earth, sending that data home wasn't instantaneous. Transmitting at just 1 to 2 kilobytes per second, it took New Horizons over a year to fully download everything it had captured during that single flyby, meaning astronomers spent months slowly piecing together a picture of an entire world, one small batch of data at a time. What emerged from that slow download was a landscape far more active and far stranger than anyone had expected. At the heart of Pluto's most famous feature, the pale, heart-shaped region officially named Tombaugh Regio, sits a vast basin called Sputnik Planitia, filled with frozen nitrogen ice roughly 2.5 miles thick in places. This nitrogen ice isn't just sitting there. It behaves like a genuine glacier, slowly flowing and churning under its own weight, the same way ice sheets move here on Earth, except at temperatures hovering around negative 387 degrees Fahrenheit. The surface of this nitrogen glacier is broken into a pattern of irregular polygon-shaped cells, some as wide as 12 miles across, a pattern scientists attribute to convection. Warmer nitrogen ice rising from below, cooling at the surface and sinking back down in a slow, continuous cycle. It's not unlike the way a pot of thick soup bubbles and churns when left to simmer, except here the entire process unfolds over hundreds of thousands of years, sculpting and resculpting the ice from underneath in real time. That alone would have been a genuinely surprising discovery on a world this cold. But New Horizons found something even harder to explain, sitting right at the edge of that nitrogen glacier. Rising along its western border are two enormous mountains, informally named Wright Mons and Picard Mons, each with a massive, gaping depression carved into its summit. Wright Mons stands roughly 2.5 miles tall. Picard Mons rises even higher, to nearly 4.5 miles. Neither one looks like an impact crater. Both, instead, resemble something scientists almost never expect to find this far from the sun. Cryovolcanoes, mountains built not from molten rock, but from erupting ice, slush, and semi-frozen material welling up from somewhere beneath Pluto's crust. The evidence pointing toward genuine, relatively recent volcanic activity isn't circumstantial. Scientists studying the surrounding terrain noticed something telling, an almost complete absence of impact, craters on and around these two mountains. Every other ancient surface in the outer solar system accumulates impact scars steadily over billions of years, meaning a smooth, crater-free surface is one of the clearest signs planetary scientists have that something has been actively resurfacing the ground, erasing old scars faster than new ones can accumulate. If Wright Mons and Picard Mons really are cryovolcanoes, and the growing body of evidence increasingly suggests they are, then Pluto isn't simply a fossil of its ancient past. It's a world that has been geologically active far more recently than anyone expected, and quite possibly is still active today. None of this should be possible without a source of heat, and that's exactly where the story gets genuinely strange. Pluto is smaller than Earth's own moon, far too small, by every conventional model of planetary heating, to retain enough internal warmth from its formation, or generate enough heat from the slow radioactive decay of elements in its core, to keep anything beneath its surface in a liquid or semi-liquid state after 4.5 billion years of cooling in the cold of deep space. And yet, the flow patterns in Sputnik Planitia, the apparent cryovolcanic activity at Wright and Picard Mons, and a series of subtle features scientists have identified elsewhere on the surface all point in the same direction, toward the possibility that Pluto still harbors a liquid water ocean, sealed away beneath dozens of miles of solid ice crust. It's kept from freezing solid by a combination of leftover internal heat and the antifreeze-like effects of dissolved ammonia and other compounds mixed into the water. One particularly compelling piece of evidence for this hidden ocean comes from a mountain range on the western edge of Sputnik Planitia called Al-Idrisi Montes. Detailed measurements of this range show something odd. The peaks closest to the nitrogen ice basin are noticeably shorter than peaks farther away. with elevation increasing steadily the further you move from the edge of the glacier alongside a deep trench running parallel to the range on its far side. Researchers studying this pattern have proposed that the entire mountain range may have gradually shifted position over time, pushed and pulled by slow, ongoing movement in the ice beneath it, a process called solid-state convection, similar in principle to the same churning that shapes the nitrogen glacier itself, but operating on the water ice bedrock that forms Pluto's crust. A static, dead world doesn't produce mountain ranges that appear to be slowly sliding across its surface. A world with active internal movement, quite possibly driven by heat rising from a liquid layer far below, does. There's also a puzzle hiding in Pluto's winds, faint as they are. Pluto's atmosphere is so thin that its surface pressure is roughly 100,000 times weaker than Earth's, barely more substantial than a very good laboratory vacuum. And yet, on the western flank of Sputnik Planitia, near the base of another mountain range, New Horizons photographed a genuine field of dunes, roughly 700 square miles of rippled, wave-like terrain built from grains of frozen methane ice, arranged in patterns strikingly similar to sand dunes found in deserts here on Earth. An atmosphere this thin shouldn't be able to move solid particles into anything resembling an organized dune field. The leading explanation researchers have proposed is a subtle, indirect process. Nitrogen ice, sublimating, turning directly from solid to gas, may loft tiny grains of methane ice into the thin atmosphere as it escapes. Faint winds then carry those grains just far enough to settle into rippled patterns near the mountains, an unexpected, almost accidental form of geological sculpting that nobody predicted a world this cold, this distant, and this thin-aired could produce. Each of these features, taken alone, might be dismissed as a minor curiosity. Taken together, they describe something much larger, a small, distant world that, by every reasonable expectation based on its size and distance from the sun, should have gone completely geologically silent billions of years ago, and yet clearly has not. Nitrogen glaciers still flow. Possible cryovolcanoes appear to have erupted recently enough to leave no meaningful crater record. Entire mountain ranges appear to be shifting position. Dune fields form under conditions that shouldn't allow for it. And underlying nearly all of these processes is the same tantalizing, still debated possibility. A genuine ocean of liquid water, hidden beneath Pluto's icy shell, quietly persisting in one of the coldest, most remote corners of the solar system. This possibility connects Pluto to a small, exclusive club of worlds that scientists consider among the most promising places in the solar system, to search for conditions that could, at least in principle, support life. Icy moons like Europa, Enceladus, and Ganymede, each suspected or confirmed to hide subsurface oceans of their own beneath a frozen crust. Pluto's potential ocean would be different in important ways. Colder, likely far less energetic, and without the tidal heating that keeps some of those moons' oceans churning as they're gravitationally squeezed by a nearby giant planet. But its mere possible existence forces a reconsideration of just how common liquid water might actually be, hidden away, unseen, beneath the frozen surfaces of small, distant worlds we once assumed were simply too cold and too small to hold onto anything but solid ice, all the way down. What makes this story particularly remarkable is how briefly we've actually had access to any of it. New Horizons captured its close-up data on Pluto in a matter of hours during a single flyby in July 2015 and then kept going, deeper into the Kuiper Belt, never to return. Every mountain, every glacier flow pattern, every hint of cryovolcanic activity described here comes from that one narrow window of observation, a single fast pass by a spacecraft the size of a grand piano, glimpsing a world in extraordinary detail for the first, and so far, only time in human history. Whatever processes are still reshaping Pluto's surface right now, in this moment, are continuing to unfold completely unobserved, exactly as they have for millions of years, waiting for the next spacecraft, whenever and if ever one is sent, to catch up with whatever changes have accumulated since New Horizons said its brief hello and continued on its way into the dark. Pluto spent most of its scientific life being defined by what it wasn't, not large enough, not influential enough, no longer even officially a planet, according to a 2006 decision by the International Astronomical Union that still generates debate to this day. But the geology New Horizons revealed tells an entirely different story about what Pluto actually is. A small, distant world that somehow, against nearly every reasonable expectation, still has an active interior, still reshapes its own surface, and still keeps at least one substantial secret. A hidden ocean, sealed away where no telescope and no spacecraft has yet been able to directly confirm it. Something is genuinely still happening down there, in the freezing dark at the edge of the solar system's known worlds, and we caught only the briefest possible glimpse of it. One single flyby, one narrow window, and an entire world's worth of ongoing mystery left behind.